So when I take notes, so I've started to record my voice. So you'll see in the videos, if you haven't experienced my videos before, you'll see me writing, and you'll hear my voice, but you won't see me. So you'll also hear me if I answer questions in class. You'll hear your questions or random things that happen in class if somebody calls on the phone or something. But that's just kind of, but you do have the option of watching this later, which can be very helpful for some people. Although I don't think you'll find today's lesson particularly difficult. I don't suspect, but we'll see. So we're going to start by defining combinatorics. It's a fancy word that is a branch of mathematics dealing with ideas and methods for counting. In complex situations. So back in kindergarten, we learned how to count. Now we're doing more advanced things of counting. So this is not about how many red crowns there are anymore. This is about how many ways we can order the crowns in the box. All right, so the first way that we use is a tree diagram. So for example 1, we're going to use a tree diagram. So Martin lives in Kingston and is planning a trip to Vienna, Austria. He checks a website offering inexpensive airfares and finds that if he travels through London, England, the fare is much lower. There are 3 flights available from Toronto to London and 2 from London to Vienna. If Martin can take a bus, plane, or train from Kingston to Toronto, how many ways can he travel to Kingston, from Kingston to Vienna? So, if we use a tree diagram to count it, so the first he can either take a bus, a train, or a plane from Kingston to Toronto. Then there are 3 choices for the flight. I might change color pens for you. So there are 3 choices for the flight from Toronto to London. So if we say A, B, or C, there are 3 ways he can take that flight. But the thing is he can take those 3 ways starting on any of these. So A, B, or C, or A, B, or C. And then from London to Vienna, I'm going to use blue maybe, he has 2 choices. For each, if he's any of these paths, he has 2 choices. So 1, 2, 1, 2, 1, 2, 1, 2, 1, and I did not give myself enough space here. Don't be like me. There we go. So if you count up this last number of branches of the tree, that's when you figure out the total number of ways that he could get from Kingston to Vienna. So how many ways are there in the end there if we count all those up? 18. So this is where I tell you that tree diagrams are pretty, but they're not very useful, because especially if you get beyond like 3 or 4 items, they can become really cumbersome, which is a fancy word that means insane. And they also just, it's like if you're getting into like the numbers of hundreds, you're not going to want to draw a tree diagram for that. So they're very pretty, but they're not useful. So this is when we do this. So if we do 3 in our first times 3 in our second choices times 2 for my last choice, I would also end up with 18. So in this case, what I'm doing is I'm counting up the choices at each stage. So this would be the first stage, this would be the second stage, this would be the third stage. And if I multiply those together, I would get the total number of ways. So far, pretty easy? Okay. Stop me if you're lost, okay? Or if your mind is blown and you just need a minute. I don't think it will be yet. So this is why, if we're moving on to this question about Javon looking at stereos, he has 5 types of receivers, 4 types of CE players, and 5 types of speakers. Nobody buys stereos like this anymore, but it's still in the textbook. Maybe my husband might buy a stereo like this. So how many different choices of stereo systems does the store offer? And again, because we've got 5, and then for each of those 5, you're going to have to put 4, and then for each of those 4, on each of those 5, you'll have to put 5 more branches. It's just way too big. It becomes ridiculous, and you need a very large piece of paper to do it. So that is why we want to avoid using the tree diagrams, unless I say use a tree diagram, and there's only like 2 or 3 branches each, right? So in this case, there are 5 receivers. And 4 CE players. And 5 speakers. So if I do 5 times 4 times 5, what would that be? 100. Good mental math. I like how fast that happened. So, therefore, there's 100 possibilities. So,
Excuse the interruption. M. Oriano DeMello, please come to the office.
So these, this really just it's a principle. There's an actual name for it. It's called the fundamental or multiplicative counting principle, and that just says that if a task is made up of stages with separate choices. The total number of choices is m times n times p. They always miss O when you do this. Dot, 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 on where m is the number of choices at the first stage. And at the second, etc. I would never expect you to repeat that to me. Just so you know, I write it down so that you have it in your notes. You can refer to it. It's very mathematical thinking, but I would never expect you to repeat that to me. Just so you know. Okay. So, using that principle, school band often performs at benefits and other functions outside of the school. So its members are looking to buy band uniforms. The band committee is considering 4 white shirts, dress pants in gray, navy, or black, and black or gray vests with the school crest. How many different designs for the band uniform is the committee considering? So 4 shirts times 3 pants times 2 vests. 4 times 3 times 2 is 24. And again, there was a time in my career when I was really adamant about writing therefore statements and stuff like that. It's really not that important to your life, trust me. Just make sure you circle the answer so I don't have to go looking for it. All right. So occasionally, though, you'll end up with something like this. There's a triathlete, Leora, is a triathlete who has 4 pairs of running shoes loose in her gym bag. In how many ways can she pull out 2 unmatched shoes, one after the other? So we're going to use the indirect method for this because there are a lot more ways for her to choose matching shoes or unmatched shoes than there is for her to choose matching shoes. So in order to figure this out, we're going to figure out how many ways she can totally choose the shoes. And then we're going to subtract the number of ways that she can pick matching shoes rather than try to figure out how many ways she can pick unmatched shoes. Does that kind of make sense to you? All right, so first of all, the number of ways to choose shoes, total. How many ways can she pick one shoe out of the bag? Yep. 8, right. There's 4 pairs, so there are 8 shoes in the bag. So this is the first shoe. So once she's picked a shoe out of the bag, how many shoes can she pick? 7. So 8 times 7 is 56. So there are 56 total ways for her to pick shoes out of the bag. Now, how many ways can she pick matched shoes? So again, we start off with picking the first shoe is 8. Once she's picked a shoe, though, how many ways can she pick its match? 1. Excellent. Is there anyone that doesn't understand where he came up with that number? There's only 1 matching shoe, right? Once you've picked a shoe out of the bag, there's only going to be 1 in there that she could pick that would be matching. So there are a total of 8 ways she could pick matching shoes. So the number of ways would be 56, which is the total number of ways she can pick shoes. Subtract 8, which is the way she can pick the unmatched shoes, which would be 48. Did we put our head down and sigh because we're tired or because we didn't understand? Sean, did you put your head down and sigh because you were tired or because you didn't understand? Okay. I'm just worried you don't understand. I gotta make sure I stop if you don't. All right. Now this gets a little bit trickier. This is where you start to maybe lose it a little bit. So, sailing ships used to send messages with signal flags flown from their masts. How many different signals are possible with a set of 4 distinct flags if a minimum of 2 flags must be used? So, with this, we can't use 2 flags and 3 flags at the same time. We can't use 3 flags and 4 flags at the same time. These are 2 different things that have to happen. And when it says, when we're looking with that, either 2 or 3, 3 or 4, that when you have to use that word or, it means that we're going to have to add something together. Because we only multiply things that are happening at the same time. So we need to break it up. And this is yesterday when you were doing the question with the boxes and figuring out how many boxes there were. This is kind of along that line. So you figure out in each category how many there are, and then from there you're given the opportunity to add them together. So if I use 2 flags, there are 4 ways to pick the first flag, and then once I've picked a flag, there's only going to be 3 ways to pick the second flag. So that would be a total of 12. So if I use 3 flags, now I have 4 times 3 times 2 ways to pick my flags for signaling, which would be 24. And if I use 4 flags, I have 4 times 3 times 2 times 1 ways to pick that, which is also 24. So because they can happen at the same time, now I have to add those together. So that would be 12 plus 24 plus 24, which would be, anybody can do that in their head? Good, 60. So there's 60 ways that you can make signals. Now this is why these questions become challenging, because it's really hard. There's little intricacies in the language that make it really hard to tell when you're supposed to use addition and when you're supposed to use multiplication. But this also is an actual rule. It's called the additive counting principle, or the rule of sum. And it involves the word mutually exclusive. There it is. So if one mutually exclusive which is just a fancy way of saying something that can't happen at the same time, can occur in m ways. A second in n ways, and a third, oh sure, I shouldn't put and in there. A third in p ways. Then there are m plus n plus p ways for these to occur. So again, good math to know or to have experienced this. I would never ask you to repeat that to me. And tomorrow we get into factorials and permutations.